Well, here I glance at this, say, okay, well, left or right? Well, you might say right, you might say left. The key is this angle doesn't match. So I have to do something. I'm going to work the side both ways. Let me start with the left. If I'm going from left to right, I know that I have to change the angle somehow. Well, since I have to change the angle and boost it up, I know 1 minus twice the sine squared of theta is the cosine squared of u in this case. And here, I know that this is 2 times twice the sine of u cosine of u. Now, normally you don't do that, but the fact that you have to really boost up the angle, you know what I meant. When I said this is this is the cosine of twice u. And since I need the angle to really be pushed up, I know what to do. And that's why it's good to always look at both sides. And isn't this the sine of 2u? And now look at the whole picture. I'm looking at twice the sine of an angle, cosine of an angle. Isn't that the sine of 2 times whatever that angle is? I know it's kind of hard to work backwards. And that's the sine of 4u. And there it is. And if I was to look at the left side, the right side, and work my way to the left, you could do that too. You could do that theoretically in every problem. Not recommended, but you know. Or I could look at this and say, look, here I need to reduce this angle to match those. So I'll say this is the sine of twice, what, 2u? And I know the sine of twice an angle is twice the sine of that angle, the cosine of that angle, whatever that is. In this case, it happened to be 2u. And again, I'm keeping an eye on the other side. I notice I don't want 2u, I want just u. So this is twice. I know this is twice the sine of u, cosine of u. And here, I have multiple options for cosine. That's why I look at this, say, well, hey, I know what that is. That's 1 minus twice the sine squared of u. And if I multiply those, that is 4 times the sine of u cosine of u times 1 minus twice the sine squared of u. So I use that to my advantage. Every time I'm looking at an identity, I look at both sides to kind of gear me how I'm going to start the problem and which direction I'm going to run. Now let me look at a few more. Looking at number 58, I want those to be the same. Left or right, I'm going to start with the left, and I notice that these angles are not the same again. And I notice the angle is up. Since this is a square, not a double, well, I know this is 1 minus the cosine of 2 theta divided by 2. And I know that this is 1 plus the cosine of 2 theta divided by 2. And if I combine those, that is all over 4. And the top, I know that a minus b into a plus b is a squared minus b squared. So when I FOIL the top, that's the first squared minus the second squared. And again, I keep an eye on the other side, and I notice the angle is still not matching. So that's going to be all over 4, 1 minus. And I know that cosine squared of 2u, again, is 1 plus the cosine of double that angle divided by 2. This is, again, a complex fraction. 1 minus 1 half minus the cosine of 4 theta over 2 over 4 over 1. I could simplify the top, or I could just say the LCD is a 2. Multiply this by 2 top and bottom. And that will be 2 minus 1 is 1 minus the cosine of 4 theta divided by 8. Since I'm going to ignore the denominators because they all have it. And that's really what's on the right hand side. I could have started with the right hand side again. That works the same way. In this case though, it was a bit longer when I attempted that last time. Next problem I'm going to look at is number 64. And left or right? Well, I noticed the right has a lot of things going on, so maybe I'll start with the right hand side. Sine of theta plus cosine of theta. And do I remember what the cubics were? What was a cubed plus b cubed? That was a plus b into a squared minus ab plus b squared. So if I apply that on the top, which is sine cubed plus a cubed, that will be sine plus cosine into the first squared minus the product of the two plus the last squared and a couple of things I noticed really quick. One, those cancel out. And I noticed this is sine squared plus cosine squared, that's a 1, minus the sine of theta cosine of theta. Again, I use this to my advantage. I would say that's 1 minus. Now, I noticed that there's a double angle. Well, this is almost a double angle with one minor change. There's no 2 there. Well, I could tag a 2. And I really don't need this denominator because any quantity is over 1. Well, I can just introduce the 2 like that, right? I could multiply by 1, which is 2 over 2. And I could say this is 1 minus. And if you look at this top, twice the sine of theta cosine of theta is the sine of 2 theta, which is what they have. So again, keeping an eye on both sides of the equation would be very wise to do. Now, since last time I gave a log and you asked for few logs, I decided to do one more of those, which is that log. I want to show this identity. Well, obviously the right side is the more complex, that is 1/2, and 2 logs with a minus in between, that will be the natural log of the quotient. Right? So keep in mind that I'm looking at both sides of the equation. I noticed there's a cosine there. This is double, this is single. Well, isn't that the sine? Oh boy. Isn't that the cosine squared of theta? Power reduction. Cosine squared of theta. Right there. Cosine squared of theta is 1 plus the cosine of 2 theta divided by 2. I'm going to go backwards. And the one property of logs, I could take a number and make it a power. This will be the natural log of the absolute value of the cosine squared of theta to the 1/2, which is a square root, and the square root of the cosine squared in absolute value is the cosine of theta. And that is, and that's pretty much how these work. The last portion of this section deals with solving equations. Solve each equation in this interval. Well, we know the drill. If they didn't touch the angle, we have 2 for each sine or cosine or tangent being positive or negative. I have a couple of options in this case. I could notice the angles are not the same, I get a match. I could work with the right, use power reduction on this, or I could work with the left and say, well, cosine has 3 identities, but since I only see sine squares on the other side, then I'm going to take twice the sine squared of theta minus 1. Right? I'm sorry, backwards. 1 minus twice the sine squared of theta. Oh boy. Oh, okay. Well, these cancel out. I'm left with 1 equal 2, and that would mean there is no solution. Right? That happens sometimes when solving equations. Alright. Another one of these problems would be 74. I'm trying to solve where does the sine of twice theta equal the cosine of theta. Again, the angles don't match. But sine, there's not much of a choice. There's one identity to deal with. And what we do, we get everything on one side, 0 on the other side. We did this back in section 2.3 if you remember, solving trigonometric equations. Factor a cosine of theta out. So it's either the cosine of theta equals 0 or twice the sine of theta minus 1 equals 0. So either the cosine of theta equals 0 or sine of theta equals 1/2. And let's see. Cosine of theta equals 0, that's a special case. That happens right there and right there. That's when theta equals pi over 2 or 3 pi over 2. That's done. As far as this, sine of theta equals 1/2, we did too many of those. One, the reference angle, meaning ignoring the plus or minus, is pi over 6. Secondly, where does the sine of theta equal a positive? Sine of theta is positive in quadrant 1 and 2. In quadrant 1, you have pi over 6, and in quadrant 2, 5 pi over 6, and those would be my 4 solutions to this equation. And the last problem I want to look at is this problem. Directions solve. Well, I know that's an angle, not the 2. I know that this is an angle, I call that theta, so I'm really looking for the cosine of twice theta. On the side, I say, well, if theta equal this inverse cosine, inverse tangent of -4/3, that means tan of theta must have equaled -4/3. Tangent is negative in 2 quadrants, but since I started the problem with an inverse tangent, I know it must be quadrant 4 because inverse tangent is only allowed to be in quadrant 1 or 4, opposite over adjacent. Well, obviously the y is negative in that quadrant, and I know this is 3, 4, 5. Now, which of the 3 identities can I use? Whichever you like. Since we used the cosine and the cosine squared minus sine squared, I'm going to say this is twice the cosine squared of theta minus 1. Again, it doesn't matter which of those you use. And all what I need is the cosine. And the cosine of this triangle is the adjacent over the hypotenuse. And that's pretty much it. There's the homework. Skip number 89 if you come across it. I'm not sure if it's on the every other odd part. And that would be it.